Hello everyone, this is your tutor AB and today we're going to be solving a problem from the May 2017 IB examinations. This is a mathematics SL paper 1 question and it relates to finding tangents and normals. So let's get started. It's a differential calculus question. A quadratic function f can be written in the form f of x is equal to a x minus p into x minus 3. The graph of f has axis of symmetry at x is equal to 2.5 and the y-intercept at 0, negative 6. And there's three parts to this question. Find the value of p, find the value of a, and finally part C, the line y is equal to k, x minus 5 is the tangent to the curve of f, find the value of k. The question is split into 3, 3 and 8 marks, so it's a total 14 mark question, so let's get started. If you don't recognize it already, this f of x is written in the factored form. This is called the factored form, meaning the second portion of this bracket, x minus p and x minus 3, 3 is one x-intercept and p is the other x-intercept. Okay, so that will help us in this question and you'll see why. If I want to graph this equation, how would I do it? Let's say A. Let's draw a rough sketch of a graph. Okay, so I know one x-intercept for this function is at x is equal to 3. Why? Because you're taking this specific value and that's 3. You're taking the absolute value of that, or not absolute value, but you're taking the opposite of whatever is in the sign, so that value is 3 right here. So this is one x-intercept, and we know there's an axis of symmetry at x is equal to 2.5. right there's an axis of symmetry. Now why is this important? I want you to recall what happens with an axis of symmetry, right? Always they're reflected across the axis of symmetry. So the distance of one point from the axis of symmetry is the same distance for the corresponding point. So for example, if this is 2.5, the axis of symmetry, and this one x-intercept is 3, there's a difference of 0.5. So the other x-intercept is at a difference of negative 0.5. So the other x-intercept is 2. Right, so you have, for example, one x-intercept is 3, the other x-intercept is now 2. So we know that the x-intercept belongs within the bracket, and as 3 takes up the point of the second bracket, you know that 2 is equal to p, so p is equal to 2. Okay, so then let's do part B. Part B is find the value of a. Now this is quite simple. Let's just create our equation. We know y is equal to a x minus 2, which is what we found earlier, x minus 3. We are also given a point of the y-intercept, 0, negative 6. This is important because we can just plug this into this equation for 0, negative 6. We can just plug this coordinate into this equation and we can solve for the value of a. So negative 6 is equal to a, negative 2, negative 3. So a is equal to negative 1. Now that's our value for a. So that's 3 marks and that's 3 marks, 6 marks right there. Finally, let's do part C, which is the 8 marker. The line y is equal to kx minus 5 is a tangent to the curve of f. Find the values of k. Now, how do we do this? Well, I would say the best way to do this question is recognize that the tangent will intersect our curve f, will intersect this equation. Hence, we can set them equal to each other. We know that kx minus 5 must be equal to our equation, and let's create our full equation with all our known values. Negative 1 x minus 2 times x minus 3. This is all our known values, right? This tangent is equal to our equation because it will intersect. That's why we're allowed to set it equal to each other. So if we expand, kx minus 5 is equal to negative 1 on the outside. Let's expand x squared minus 3x minus 2x plus 6. So again, if I properly write it all together, I get negative x squared plus 5x minus 6. This is equal to this. So we can solve for k. How though? We would use the discriminant. What is the discriminant? b squared minus 4ac. This will give us the solution to this problem, because we know there is one solution. There's only one point which the tangent intersects the curve. We know that this solution of b squared minus 4ac must be equal to 0. So let's bring it all to one side. We get negative x squared plus 5x minus kx minus 6 plus 5 is minus 1. And that's equal to 0. But we also know that b squared minus 4ac is equal to 0. So what is b squared in this case? If we factor out an x, you get x, 5 minus k. So 5 minus k is our b. We know that a is equal to negative 1, and we know that c is equal to negative 1. So let's substitute everything inside. So b squared is 5 minus k the whole square minus 4 times a, which is negative 1, times c, which is also negative 1. And this whole thing is equal to 0, because there's only one solution. There's only one point at which the tangent intersects the curve. So expanding this out, binomial expansion, we just get 25 minus 10k plus k square minus 4 is equal to 0. So if I rewrite this properly, k square minus 10k plus 21 is equal to 0. Now we can factorize our quadratic equation. You can use whatever method you like. You can use quadratic formula or whatever. I just like to factor it fast. So I immediately know this is k minus 7, k minus 3. Right, that just comes with practice. So if I set it equal to 0, k is equal to 7, or k can be equal to 3. There are two possible values for k for this question, and so that's our answer. So I hope you learned something. Please do like and subscribe, and if you have any questions, please feel free to comment below and I'll reply to it as soon as possible. Please like and subscribe. Thank you for watching.